Well, hello everybody. We're ready to start chapter number 9. It's on rational functions. I'll be giving you some information, if you haven't got it already, on testing on that last chapter. We're just going to test you to see how well you're doing on that. All right, rational expressions. What is it? Well, the word rational, and we have talked about this before, the word rational has the word ratio in it. And a ratio is this comparison of two things using a fraction, something like a over b. And if you remember, the definition of rational was any number that can be expressed as a over b, where a and b are integers, and b is not equal to 0. Now make a note of that. B is not equal to 0. We'll talk about that again. Again, you can't divide by 0. So we'll discuss what that is. So we're going to be dealing with expressions and equations that are fractions, basically. And rational, fractional, they almost rhyme. And we're going to be dealing with things that are fractions. The most common, the simplest rational expression is something that looks like this, where the x is in the denominator. Most of the time when we see functions, the x is not down here, it's usually on the top. So rational functions have variables typically in the denominator. If it doesn't have a variable in the denominator, we just call it a polynomial. So that's the basics of what a rational expression or an equation is going to involve. It has been a fraction where the variable is in the denominator. All right, it needs to be mentioned right here at the beginning of this chapter, a discussion of domain restrictions. If you recall, domain restrictions were talked about way at the very beginning of the school year, talking about what can x not be. The word domain here means the acceptable values for x. So what can x not be? Well, you know that in almost everything we've done here so far, we've talked about domain restrictions. For example, with square roots, x underneath a radical, x must be greater than 0. Can't have a negative radical here to get a real answer. Also, there are domain restrictions on things like area and volume. X here, these numbers cannot be, on a rectangle, these numbers cannot be 0 or less than 0. So the domain for some kind of polynomial or some kind of area or volume problem, the sides have to be greater than or equal to 0. We could say the length and the width. The length and the width have to be greater than or equal to 0. You can't have negative numbers for distance, and you can't have 0 as a distance. Also, maybe you recall that we also talked about domain restrictions in situations where variables are in exponential functions. For example, x here, let's just call it b. b x equals y. We had a restriction on the base here. We said that the base must be greater than or equal to 0, and the base cannot be equal to 1. So there have been restrictions all along here on different things. Well, the one we want to talk about here today is the fact that in fractions, the denominator cannot be equal to 0. Remember, a over b, where b cannot be equal to 0. It's not allowed to divide by 0. And if you'd ever tried dividing by 0, you'd get an error on your calculator. So looking at this problem here, what could x not be? So on this particular problem, if I set the denominator equal to 0 and solve it, I see that the denominator cannot be 2. So x cannot be equal to 2 is the domain restriction on this problem. You're going to need to keep an eye on this all the way through this chapter, that anytime you solve a problem, you have to check back at the domain and see, oh, am I restricted here in the denominator? So this is all about checking the denominator. Let's look at a couple of those. All right, here's a common rational expression. And before we actually simplify these, which we're going to talk about here in a second, is we want to take a look at what x cannot be. Well, if I set each of these factors in the denominator equal to 0 and solve each one, I can see that x cannot be 5, otherwise this factor would be 0. And over here, I might have to factor this first. You recognize that's the difference of squares. It factors to x plus 1 and x minus 1. Then if I set each one of those equal to 0, I see that x is negative 1 and x is 1 would make that denominator 0 there as well. So x cannot be 1 and negative 1, or it cannot be 5, or this fraction has no meaning. We're going to be using that information later, much later on, in helping us to graph these problems. So as you do these problems, you may be asked to determine what the domain restriction is on the problem. All right, let's talk about simplifying. Before we do that, we're going to have to go back and take a look at fractions for just a second. Fractions in general. All right, we're going to be asked to simplify fractions, and that means a lot of different things. But one of the things it means is, can I reduce this? And reducing means, can I divide the top and the bottom by the same number? And as I look at this fraction, I can see that 7 goes into both of these. So I divide 7 into the top. I'm going to show it here, but I don't need to usually write it. Dividing 7 into the top and the bottom, it gives me 2 over 3. So we can simplify and reduce fractions. And so in order to do these problems, you're going to need to try to reduce them if possible. Now, let's talk just a little bit about something that's going to come up in the future. But if you had a problem like this, there it is. Now, we're going to say, well, let's reduce this. And somebody might be tempted to go, oh, let's cancel these 3's. But reducing only works with factors or products. I can't reduce these because these things are addends, A-D-D-E-N-D-S. They're added. This is really equal to 5/8. And if you try to reduce addends in the problem, let's say I would cancel this. 3 cancels 3. I'd end up with 2/5. Well, 2/5 is not anywhere close to 5/8. So you cannot cancel addends. You can only cancel factors. Try to hang on to that. That's going to come up in some complicated problems. Let's look at a harder one. All right, here's a problem with a lot of add-ins on the top and a lot of add-ins on the bottom. And you might be tempted to say, well, let's reduce this. Well, we can't cancel add-ins. Somebody might say, well, let's just cancel these x squared. Can't do it. Those are add-ins. Somebody might say, oh, let's cancel the x's. Can't do it. Somebody might they say the answer here then is 5 minus 2 over negative 2 plus 1. There's no way that this is possible because you're canceling add-ins. You must cancel factors. So hang on to that. Don't forget that part. All right, let's try simplifying for the homework tonight. All right, your instructions are just going to say simplify. So as we look at these problems, these are nothing but factors on the top and nothing but factors on the bottom. 4 times A times 15 times B times B. Same thing on the bottom. And so we're simply looking for places in which we can cancel items on the top with items on the bottom. And of course, remember that it doesn't matter the order when you're multiplying. So something over here might cancel something way over here. It's okay as long as they're all factors. Well, I can see initially here, let's start with a 4. I'm starting on the left here. 4 and 16 can reduce. 4 goes in here once, and 4 goes in here 4. Now you'll notice I'm crossing the numbers out, but I'm not scribbling them out, just crossing them out and writing the new number in there. Okay. I see that A and A cubed can be reduced, so A and A go into both of these, so let's just cross that off and make it a 1, and cross this off and make it a 2. Now it's A squared instead of A cubed. 15 and 5 will reduce. 5 goes into 15 3 times. 5 goes into 5 once. And then B squared and B. Well, B goes into both of those, so B goes in here once, and B goes in here and takes care of one of those B's. Now, I've done a lot of crossing off here, so I have to look very carefully to see what's left over. Well, there's a 1, and a 3 and a b. You may need to do this in more than one step. I got a 1 and a 4 and an a squared. Well, there's our reduced answer. And I did it all in one step, but you may have done it differently. You could have possibly just spread this all out and reduced it a different way, but this is usually the simplest way to do it. Let's take a look at another one. All right, I put a problem up here that has division in it. Now, from what you remember about dividing fractions, you will keep this fraction the same, change the middle here to multiply, and flip this fraction over. So let's do that. I'm going to write it out. I don't really want people to just try to cancel without changing this because it's too many places to make mistakes. So I'm going to copy this over on the left, change to multiply, and flip this other fraction over. And now we can go ahead and reduce. I think if you try to do it too early, you end up making errors on it. So remember, it's keep this one, change the middle, flip the one on the right. Let's see what we can reduce. Well, let's see, 4 and 2 can reduce. This becomes a 1. I got x squared here and an x down here. Let's cancel this x and call this x to the first. Y and y squared, let's cancel the y and call this y to the first. 5 goes in here once, 5 goes in here 3. A cancels with one of these and makes it a 2. And the b cubes completely go out. So there you go. Trying to do all this canceling without it flipping it over would be really confusing. So what have I got left? I got 2 times x. And I've got nothing else over here but 1s. On this side I have 3 and a squared left. And I've got y to the first over here. So our answer would be 2x over 3a squared y. Once again, you can reduce these, but you have to flip that right fraction if you're dividing. Now I want you to see what this problem would look like if it was written a little bit differently. Let's do it a different way. All right, I've rewritten this problem at the top here to look like this. This sign means divide. And here I've actually got a divide sign here as well. This is what we call a complex fraction. Complex fractions are fractions within fractions. This has got a fraction inside of a fraction. So I could write it this way or I could write it this way. This looks more confusing to people usually, but really in the same way we're doing exactly the same thing. This is the fraction on the top divided by the fraction on the bottom. If I take this fraction and put it up here and flip it over, I'm flipping it over. Remember, it's keep, change to multiply, and flip. Same thing, keep, change, flip. And I flipped it over. Oops, that's a 2 there. 5ab cubed and 2xy squared. Now I can do the same thing I did on the last problem. Complex fractions aren't that complicated if we just remember that you can flip it over. Now let me show you another reason why this works. I'm going to back up here and show you another reason why it works. If I multiplied top and bottom by this reciprocal, and sometimes that's a thing to do, multiplying the top and bottom by the reciprocal. Now notice what I've got here. This is just 1. The top and the bottom are identical, and so this is really just 1. I haven't changed the problem. But what happens on the bottom? Well, all of this cancels away, and I had what I had originally. That's a third way to do the problem. Obviously, this one takes much longer because you have more writing to do. But whichever way you do it, you're going to have to keep, change, and flip this bottom fraction. That's the normal process that we have been working with fractions for a long time. All right, let's try some polynomials and binomials here. All right, here's a problem a little bit like one of the examples I had at the beginning. Let's remind you again that we can't just cancel these x squareds because these are addends, or the x's or the numbers. We can't cancel them. And so some might look, well, what does cancel? There aren't any factors in this problem at all. So we need to create some factors, and we look at this and go, maybe I could factor this thing on the top. And it turns out we can. What two numbers will give me -8 when I multiply and 2 when I add? Well, that would have to be +4 and -2. Now, if you need some extra paper to go out and factor that, 4x and -2x, you could factor these on another piece of paper or on the side if you want to. Over on the bottom here, then, we got another thing. What two numbers will give me 3 when I multiply and 4 when I add? Well, this is a trinomial that factors as well. This would be x plus 3 and x plus 1. I got 4x in the middle. That works. Over here, I look at this and go, oh, this has got a greatest common factor. Let's take out a 3 and leave behind x plus 1. And then on the bottom, we still have the x minus 2. Now, I'll put parentheses around the x minus 2, but it really doesn't need it because this bar acts like a parentheses anyway. But I'll put parentheses around just to make a point here. These are all factors now. Everything that's in a parentheses is a factor in its own right. And so we can reduce by canceling. And you can see x plus 1 can cancel x plus 1. And again, because this is commutative property, we could rearrange these any way we wanted to. And x minus 2 cancels x minus 2. And we end up with this. Now, I can't cancel 3 and this 3 here because that's an addend. So my final answer, if I distributed that back in, I got x plus 3, or x plus 4 times 3 over x plus 3. And if I distributed that back in, I get 3x plus 12 over x plus 3. Either of these answers is pretty good, but usually we try to get rid of the parentheses. So you see the process here is look at the item, the trinomial or the binomial, whatever, see if it can be factored. And then once you have factors, you can try to reduce by canceling. Let's try a little harder one. All right, here's a problem that's sort of a combination of the last two problems that we did. Since this is division now, we're going to keep the left one, change to multiply, and flip this one. We could do it after we factored, but I want to do it now so I don't forget. So I'm just going to copy the left one over, change to multiply, and then flip this one over. Keep, change, flip. Now, again, we cannot cancel here because there are no factors. So this looks like that's a factorable, so let's bring this one down. That's the difference of squares, and I can see that would factor to a plus 3 and a minus 3. You may have to go back and review your factoring toolbox again. And this guy on the bottom, well, let's see, what two numbers will give me -12 when I multiply and 1 when I add? Well, they'd have to be different signs, and they're going to be 1 apart, so I think that's going to have to be a plus 4 and a minus 3. Is that right? -12, 4a, -3a. There you go. Now, we're looking for things that can reduce and factor. So we got factors all over the place here. Remember, this bar acts like a parentheses, so I don't need to write the parentheses here. A minus 3s are going to cancel. A plus 3s are identical. And I'm left over with a plus 2 over a plus 4. Now, don't cancel the a's here because they're add-ins now. So there's our answer. It's fairly simple process, all of these to do. You're going to have to factor any trinomials or binomials and see if you can reduce it by canceling. All right, let's review a little something about negative signs. You know, when I take a number and divide it by another number, either if one of them's negative and the other one's positive, I end up with a negative. Or if I turn that around, one's positive and the other's negative, I can get a negative as well. So these three are all equal to each other. And you're going to need to bear that in mind as you're doing these problems. The preferred way to do it in this chapter is to try, well, don't do this one if you can. Just take that negative and move it up to the top. This is not usually allowed. It makes it more difficult when the denominators are different like that. But this is usually the preferred way to do a problem. Now, if you had something like a negative a plus 2 over 5, this negative sign is actually going to have to get distributed into both of these if you wanted to turn this, get this negative out of the middle and put it on the top. This would actually be a negative a minus 2 over 5. Take a good look at that again. That's saying we're subtracting this entire numerator here. So I'm going to subtract the first one and the second one. So if you need to move the negative to the top, make sure you distribute that negative in. This is one of the most common mistakes that we make, is people just assign the negative to the first item but not to the second. Make sure you distribute that in. Let's take a look at a problem where this occurs. All right, let's take a look at this particular problem. We can't cancel things here as long as there's add-ins involved here, so we're going to have to turn these to factors if we can. Well, looking at the top, I can see that I can take out a z squared. And when I do, I'll end up with a w minus 1. On the bottom, I can take out a z cubed. And I'm left over with, well, I got to leave something behind there. That'd be a 1 minus w. Now, canceling is possible. You can see the canceling that's going to occur over here with z's. I can see that I'm going to end up with a z on the bottom. But since these are backwards, what I really think I ought to do is multiply negative 1 times this item here, and this would end up putting, if I multiplied it this times a negative, right, negative 1 right here, and over here times a negative 1 again, I really haven't changed the denominator here. I've multiplied negative 1 times negative 1. I haven't changed it, but what I end up with right here now is negative 1 plus w, and the top is w minus 1. Well, these are the same. They may not look the same, but this is w minus 1 over w minus 1. But I still have that negative 1 here that I multiplied that times. So I've got the negative, got the negative 1 right here. Okay? That negative 1 came down. That negative 1 got distributed in. Okay? There's a couple ways to think about doing this, but basically I'm multiplying that by a negative 1. So these end up canceling, and we end up with 1 over a negative z. We don't like seeing that negative on the bottom, so let's just put it up on the top. There's a couple of ways that you probably could have done this problem. Keep an eye on this, that if we just multiply this guy by a negative 1 and then make up for it by multiplying it by negative 1 again over here, we'll end up solving the problem. I could have done this another way, and let's do it. Let's back up and do it a different way, okay? I'll back up here and do this problem a slightly different way. Maybe you'll like this second way a little bit better. What if I multiplied the top here and the bottom both by a negative 1? That makes more sense to most people. And down here, I'm going to distribute this one in, but I'm not going to distribute the other one in. I'm going to leave it outside. So again, let's cancel the z's, and we end up with a z on the bottom. And this on the top, I'm going to leave it the way it was. I'm not going to distribute it in. And on the bottom, when I distribute that negative 1 in, negative 1 times negative w is w, negative 1 times 1 is a negative 1. I end up with the same answer I had before. The only difference is I multiplied top and bottom by a negative to make up for each other. So when this cancels away, we end up with negative 1 over w. Most people tend to like this technique a little bit better. Just distribute one of them in but not the other one, and it usually works. All right, let's take a look at your homework for today. All right, this is going to be the first assignment on Chapter 9. We're going to call this assignment P, Section 9-1, page 476, 4 through 40 even, and 47. If you get puzzled on any of these, you can try to do an odd one and check the odd answers in the back of your book. Or you can go out to the website and see if you can figure out, find the even answers on our answer website that we're using. They may be doing problems a little differently on there. Just be aware of that than I've done them here. So go ahead and give this a shot. We're only going to do one day on this assignment, so make sure you have a good handle on this. And we're going to move on to adding and subtracting rational numbers next time. All right, take care.